In this problem, we will practice calculating partial molar quantities. Here, we're going to look at describing the volume change in mixing of a mixture that contains ethanol, which we'll refer to as species 1, and methyl butyl ether, which we'll refer to as species 2. Here, the temperature is going to be 25 degrees Celsius, and at this temperature, we could describe the volume change upon mixing for this blend using this expression here. Okay? We're told that the pure molar volume of species 1 is this, and the pure molar volume of species 2 is this, and that when we make this mixture, we combine 750 centimeters cubed of pure ethanol with 1500 centimeters cubed of methyl butyl ether. And so for this mixture, what we want to calculate is what would the volume of the mixture be if the mixture formed an ideal solution, what is the actual volume of the mixture, and then what are the partial molar volumes of both components in the mixture above. And so based on this problem statement, I want you to pause the video here and sort of sketch out a diagram to describe this problem. And so based on this problem statement, we could sketch out a diagram that looks like this. And so for these sort of mixture problems, the one way to think about it, or to describe it, is you have your pure amount of species 1, which once again is the ethanol. We have this volume and this molar volume that describes the ethanol. Similarly, we could describe the same things for species 2. And so we take these pure components and we mix them together to get a mixture where we don't know the total volume and we don't know the partial volumes of species 1 and species 2. But what we are told is that we could describe the molar volume of mixing using this expression here. And just to kind of simplify the math later on when we're taking a bunch of derivatives, these constants in the expression, I'm just going to refer to them as alpha and beta. So alpha is the negative 1.026, and the beta is the negative 0.220. Okay? And so for part A of this problem, what we want to do is we want to calculate the ideal solution volume of the mixture. And so for ideal solutions, we essentially say that the total volume is just going to be a weighted average of the partial molar volumes, or of the molar volumes of the pure species. Okay? And so in that case, we would have N1 molar volume of pure species 1 and N2 molar volume of pure species 2. These we were given in the problem statement, but we need to calculate the moles of species 1 and species 2. And we could do that using the volume information that we were given in the problem, where we were given the total volume of the pure ethanol, and if we divide that by the molar volume of the pure ethanol, that will give us moles. Okay? And so here, we're going to end up with 12.79 moles of ethanol. And we could do the same thing with species 2. Here, we end up with 12.66 moles of the methyl butyl ether. And so even though the volume of the methyl butyl ether was double that of the ethanol, the amount of moles, we actually have slightly more ethanol than we do have methyl butyl ether. Okay. We'd also calculate the total amounts of moles. And we could also calculate the mole fractions of each species. All right? And so now that we have all this information, we could calculate the ideal solution volume. Q per mole plus 12.66 mole and we get 2250 centimeter cubed. Okay. All right. And so for the ideal solution, we would expect the mixture to have this volume. And if you actually just take a look at the V1 and V2 values we have here, you'll notice that this final volume is just equal to that V1 plus V2, right? And that fits the idea that with the ideal solution, right, you would just expect your total volume to just be equal to the sum of the volumes of the pure components. Okay? And so that's how we get the ideal solution volume. But in reality, we know that the actual volume of the mixture is going to be different than that of the ideal solution, right? And so to calculate the actual volume of the mixture, what we're going to do is we're going to take the ideal solution volume and we're going to add the contribution from the change in volume upon mixing. Okay? Right? So this term, this accounts for the non-ideality of the mixture. So if there's differences in interactions or molecular sizes between the two species. Here, our delta V mix is for the molar volume. And so to turn it into an actual volume contribution, we need to multiply by the total number of moles. Okay? And so for delta V mix, we have the expression from up above, this one. So I'll write it down here. And we could plug in. Negative 1.026 centimeter cube per mole minus 0.220 centimeter cube per mole, 0.503 minus 0.497. Okay? And so our delta V mix, which once again describes the non-ideality of the mixture, is negative 0.257 centimeter cube per mole. Okay? We take this value, plug it into here, and we get that the actual volume of the mixture is only 2243 centimeters cubed. And so, due to non-idealities between the ethanol and the methyl-butyl ether, we find that the actual volume of the mixture is slightly lower than that of the ideal solution.